In The Adventure of the Silver Blaze, Sherlock Holmes famously solved a case by noticing that the dog did not bark. So, clues like this, where things that are missing also lead to important conclusions, have been used by humans all the time. For example, another example is, say, distinguishing two people who look, say, very similar. Say the person on the left is Bob and the person on the right is Steve. The only difference between them being that Steve wears glasses. So if you were to describe someone who Bob is, you would say that he probably wears a yellow helmet, he wears a yellowish shirt, but does not wear glasses to distinguish him from Steve. So such explanations are very natural for us humans. And this is not only present just for explanations in social settings, but doctors heavily use such explanations when diagnosing patients. For example, you might go to a doctor with, say, symptoms of cough, cold, and fever. And these symptoms could either mean that you have flu or you have pneumonia. And it's not clear from just these symptoms. However, the doctor may further check you and ask you if you had any chills or did you have any sputum. To which, say, you answer no, then the absence of these symptoms would lead to the doctor to conclude that you have flu rather than pneumonia. So in this example too, we see that not only the things that are present, such as cough, cold, and fever, but the things that are absent are critical in coming up with a final decision. So we wanted to build a method which mimicked this at IBM Research, and we recently did, where we not only highlight what should be minimally and sufficiently present to justify a classification, but also what should be necessarily and minimally absent for the original classification to be maintained. And this is new since most of the current methods mostly focus on positive and negatively relevant features which may not be necessary or sufficient to justify the classification. So for example, if you look at these three images on the bottom left, the original image, which is on the far left, which is just white, was predicted as a 3 by a neural network. Now the next two images are our explanations. So in the middle image, what we see is the cyan pixels are highlighted by our method saying that this is what the neural network is using to classify this image. And these are not just positively relevant, but are minimal and sufficient for the neural network to produce its classification. So in other words, if we just select the cyan pixels and black out everything else and pass it as an input to the neural network, the image will be classified as a 3. However, additionally, what we say is that if you look at the image, the rightmost image, we say here that if the small pink horizontal line was present in the original image, then this image would no longer be classified as a 3, but would be classified as a 5. And so, to maintain the original prediction of the neural network, it is necessary that this small horizontal line remain absent. Given this, our overall explanation would be of the form which is shown in the highlighted box, that the original image is a 3 because the cyan pixels are present and because the pink pixels are absent. And thus, this leads to much more well-rounded explanations. We have applied this method not just to digits, but also in other domains such as fraud detection and on brain connectivity data sets where we distinguish autistic brain activities from activities in brains of normal individuals. And we have seen actionable as well as operationally significant results in all these domains. Now, for more details, you can look at the paper on arXiv, whose link is provided here. There's also code on GitHub. And this paper was recently covered by Forbes uh, as an interesting paper in terms of how interpretability of machine learning models can be made to match our human kind of explanations. Thank you.